Hello everyone, so I'm Dawson Yang, and today I'll be talking about the direct product of groups. So this first slide I have up is just explaining the basics of groups, and groups are essentially, if you don't know, are a set of numbers or objects that are combined with another set of objects, and an operation is given to them, such as multiplication, addition, division, so on and so forth. In other words, you could take, let's say, two objects, let's just call them A and B, and you can apply a function to them, such as adding the two. And you can call your resulting group R. So it could be group A plus group B is group R. And groups have four different properties called closure, associativity, identity, and inverse. Groups are written in angled brackets, and there will be two things inside of it, the set and the binary operation. So pretty much for the direct product of groups, the direct product of groups is an operation that will take two groups, let's say G and H, and it will multiply them together to make a new group that is written as G times H. Within abelian groups, which are commutative, the direct product of groups is the direct sum, and it is an important part in the classification and definition of abelian groups. The group G times H will follow the three properties of groups, associativity and identity and inverse, in the slide that I said beforehand. Next, we will talk about how we can, use this. So, for example, if we're given groups G1 and G2, as written here, with no restrictions, the direct product is a method we can use to combine these two groups into a larger group, called G1 times G2. And essentially, if you made G1 7 and -1, and G2 -3 and I, doing this would just be multiplying the two together. Just 7 and -3 and -1 and I. And something, I guess you could say, weird happens when you multiply something with the identity element. The identity element of a group is noted as E1 and E2, where E1 is the element of G1 and E2 is the identity element of G2. So, next picture I have up is a picture of a milkshake. You might be thinking, why a milkshake? So I would compare the direct product of groups to a milkshake because the volume of a milkshake, or how much liquid is inside it, is bigger or smaller depending on the amount of ingredients you add to it. So let's say the direct product of a milkshake is the amount of milk and the amount of strawberries. The more strawberries you have in it, or the more milk you have in it, will increase the amount of liquid that you have overall inside your milkshake. This is a very big concept in the direct product of groups. So I'd also like to talk about something in chemistry related to the direct product of groups. So an application that can be used is to study the chemical building blocks of atoms and their bonds. And direct product of groups helps us attain this because atomic structures revolve around a three-dimensional space, and they fit together in certain orientations. And this, the direct product of groups will help us understand how they can become stuck together. Like these two electrons here, they're stuck together, and these two atoms as a whole are just stuck together. So yeah, that's my presentation on the direct product of groups, and I hope you enjoyed. Thank you so much.